Hey guys, it's Mr. Custodio here, and today we're gonna talk about how to solve a linear system by just graphing. So target one is graphically solve systems of linear equations, including those with one solution, no solutions, and infinitely many solutions. So example one, it says solve the system by graphing. Well, one thing we need to point out right away is that a system is when you have two or more linear equations grouped into one. And when it asks us to solve the system, we are looking for the one point in which both lines will intersect each other. So one thing that I want to point out is that when you solve a system, and today we're solving by graphing, you want to, as much as possible, keep your systems organized. So I'm going to first label each equation 1 and 2. I'm going to use colors in order to identify what equation goes with what, and according to my system, we've been always solving equations, linear equations, specifically in slope-intercept form. Both equations need to be in slope-intercept form if you are solving the system by graphing. It's very, very important that each equation is in slope-intercept form. It makes life a lot easier identifying your slope, identifying your y-intercept, and then graphing from there. So let's take the first equation, 3x plus y equals 9, and I need to turn this equation that's currently written in standard form into slope-intercept form. So I'm going to subtract 3x from both sides, and now we are in slope-intercept form. That was pretty easy. So then on the right, I'm going to create my system again and almost like rewrite it so that I can organize my work, and I know that the first equation is the same as y equals negative 3x plus 9. Now the second equation in orange, x minus y equals 1, that also needs to be written in slope-intercept form. So I'm going to take my equation x minus y equals 1, and I'm going to bring the x to the other side by subtracting from both sides, leaving me with negative y equals negative x plus 1. And because I'm not quite in slope-intercept form, I need to divide both sides by a negative 1. So if I divide by negative 1, and negative 1, I'm left with a positive y equals a positive x minus 1. Now my second equation is in slope-intercept form, so I'm going to add it to my system on the right. And now my system is in slope-intercept form. Both equations are in slope-intercept form, which makes my life a lot easier when I graph it. Now one thing that you need to do, especially when you are graphing your lines and you're trying to solve a system by just graphing, you have to use a straight edge. So you can use your ID, you can use a ruler, a straight edge. It'll give you the most accurate estimation from your graph, and you want to make your graphs as accurate as you can, especially if you're just eyeballing it on your coordinate plane. So taking the first line, y equals negative 3x plus 9, I'm going to graph my y-intercept at positive 9, and since my slope is negative 3, I'm going to go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, and then connect my dots with a straight edge. And there's my line, there's the graph of the first equation in my system. Now my second equation, y equals x minus 1, well, my y-intercept's at negative 1, so I'm going to plot a point at negative 1 for y. And then I know my slope is 1, so I'm going to rise 1 over 1 to the right, rise 1 over 1 to the right, rise 1 over 1 to the right, and then using a straight edge, I'm going to connect all of my dots, including my arrows as well, because we're graphing lines. Now, where the two lines intersect, that point is considered our solution. So since we're just graphing, again, it's very important that you do use a straight edge. We have to estimate where that point might be. And according to our graph, since it's scaled by 2, it looks like it's actually at 2.5 and 1.5. that would be my solution of my equation, or I'm sorry, of my system of equations. And I bet, since this is my x and this is my y value, if you were to substitute 2.5 into this equation, so 2.5 minus 1, you will get 1.5. So likewise, if you substitute this 2.5 into the first equation for negative 3 times 2.5 plus 9, I guarantee that you will get 1.5 for your y. Because both solutions intersect at 2.5 at 1.5, both points, that one point will work for both equations. That's considered the only solution of our system. So remember to pause the video, write down any questions. If you have to rewind the video, that's fine. Write down any questions that you have on the sides in case you did not understand fully of or what we did to solve the system. Alright, during the You Try Nows, there's 4 of them. I suggest that you pause the video, try these on your own, and use colors, use a straight edge, take your time, and then check your answers when you are finished. Alright, so it looks like the graph, the two lines intersect at negative 1, 8, and that is our solution for the first You Try Now. Alright, the second You Try Now, again, pause the video, then check your answers after you are completed on your own. So the second You Try Now, the answer is 2 comma negative 1. If you don't understand how we get those answers, make sure you write these questions down in your notebook. Alright, so the next 2 You Try Now is 3 and 4. I'm just going to give you the answer. I expect you to understand how to solve each of these systems by graphing. So I'll just give you the answer real quick. You should get negative 1, 1. And then for number 4, you should get negative 2, negative 4. Alright, so don't tell anybody if you've watched this video. I want you to draw a heart at the top of your notes, and that'll ensure that I know when I check your notes the next day in class that you've completed and listened to the video. Alright, thanks guys, and again, make sure you guys watch or you write down your questions on your notebook or in your notebook and ask lots of questions, especially if you don't know. Have a good day.